Okay, so here we go. So now we are in 9.2, which is going to help us be able to find the zeros a little bit faster than if we were to just graph the quadratics. So it does recall our factoring, which we will go over in a little bit, but go ahead and pause the video and try this little warm-up first. Okay, so it says write an expression for the length and the width. So the length and the width. So this would be 4 plus this x. So width would be x plus 4. And then the length would be the 6 plus x. And then it says write an expression representing the area of the entire wall. So this whole thing. So we would do x plus 4 times x plus 6. You can do the box method. Oh, doesn't like me drawing over there. You can do the box method. You can do the FOIL method. So x times x would be x squared. X times 6 would be 6x. And 4 times x would be 4x. 4 times 6 would be 24. And then we would combine our like terms. So the entire area would be 10x. Okay. Then how can you determine the area of the part of the wall that the artist has not yet covered? So he's covered this much already. So covered would be 4 times 6, which is 24. And so you would take that and subtract it from this. So x squared plus 10x plus 24. And then we would subtract 24 from that. So these two would go away and we would be left with x plus 10x. And this would be our final answer for that C1. Okay, so now we're going to look at some new stuff. Zero product property. I think you'll all really like this because it just means that, and I'm going to go ahead and write it and then, so like I was saying, that it just says that if you have two things multiplied to each other that equals 0, so a times b equals 0, then either a is b or b is, then a is 0 or b is 0, or they're both 0. So we get to use that in order to find our zeros or our solutions to quadratics. So how can we find the solution of this equation here? If this times this equals 0, then either x minus 9 equals 0 or 5x plus 2 equals 0. And then we just solve. So x minus 9 equals 0. So we add 9 to both sides. And so then x equals 9. Or 5x plus 2 equals 0. So subtract 2 on both sides. 5x equals negative 2. Divide by 5. X equals a negative 2/5. So our answer is x equals 9 or x equals negative 2/5. A lot quicker than graphing. Go ahead and give the next two a try. Okay, so either 2x minus 1 equals 0 or x plus 3 equals 0. So we solve, adding 1 on both sides, divide by 2 on both sides, we get x equals 1/2, or subtract 3 on both sides, x equals negative 3. Again, if you have any questions about any of this, please email Ms. Holstead and I. We do not know if you are not understanding something because we don't get to see your faces while we're teaching this. So you have to email Ms. Holstead and I so that we can help you sooner than later. Okay? So then for this one, we got 2x plus 3 equals 0, or we got 3x minus 1 equals 0. and then we use the opposite of PEMDAS to solve, or the opposite operation that's here. So it's adding 3, we're going to subtract 3. Okay, we get that answer there. Again, I'm going to say it again. If you have any questions, please email Ms. Holston and I so we can help you. Okay, example 2. So now we are given a function and it's not in factored form yet, so we have to go back to some material that we learned in the beginning-ish year, and that is we have to factor it. So the first step is to make sure that it equals 0. So when it says standard form, we just got to make it equal 0. So right now we have x squared plus 9x equals negative 20. So we're going to add that 20 to both sides. Now this doesn't have an x, so it's not going to be added to that 9x. It's going to go right on the other side of it. So we're going to have plus 20 equals 0. So again, the x squared can't go with the x. They're not like terms. The 20 can't go with the x squared or the 9x. It goes to the other side of it. Okay, so that's step 1. Step 2 is we got to factor this. So if you remember, factored means what multiplies, so I'm going to write an x, to c and adds to b. And remember, ax squared plus bx plus c. So we're looking for what multiplies. I did it the other way on the other note, so I'll do it this way. What multiplies to c and adds to b. Okay? So in this case, our c value is 20 and our b value is 9. So we need something that multiplies to 20. So we have 1 and 20, 2 and 10, 3 doesn't go in, 4 and 5, and then that's all the factors. So now we need to see which ones we can add or subtract to 9. Well, 1 and 20, no. 2 and 10, no. 4 and 5, yeah, we can do 4 plus 5 and get 9. So now we just write it. And to get the x squared, we just have an x there and an x there. And we're still going to have it equal 0. And so we said they're both positives. So we have plus 4 and plus 5. If you have any questions on factoring, please email us. Okay, I know it was a while ago, so we are happy to help. So then the next thing is we use that 0 product property and solve it. So either x plus 4 equals 0 or x plus 5 equals 0 and solve. Minus 4, x equals negative 4, or minus 5, x equals negative 5. Okay, so using that, go ahead and try the next 2. Okay, so for this one, step 1 is done. It is set to 0. So I put a little check mark in my pink. Okay, and the next step is factoring. So we're looking for what multiplies to 64 and adds to 16. So we have 1 and 64, 2 and 32, 4 and 16, 8 and 8, and I want them to add to 16, so I'm going to use the 8 and 8. So I have x plus 8, x plus 8. Just so you know, this is also the same as x plus 8 squared equals 0, okay? So they're the same, so we only need to solve it once. If you solved it twice, it is absolutely okay. So x plus 8 equals 0, subtract 8 on both sides, so x equals 8. Okay, and then on this one, our first step is minusing that 64 on both sides because it's not set to 0. So we're then at x squared minus 12x minus 64 equals 0. So again, I wrote the factors of 64, 1 and 64, 2 and 32, 4 and 16, 8 and 8. And then we want it to add to negative 12. So the reason I stopped here is because I wanted to make sure to go over this while I talk through it. So negative 12, and we want a negative 64 when we multiply. To get a negative 64 when we multiply, we need one negative and one positive. So we either need negative 4 plus 16, or we need positive 4 minus 16. And so then how can we get that to a negative 12? Well, this would equal positive 12, and this would equal negative 12. So we want a positive 4 and a negative 16. So again, we wanted a negative 64 when we multiply these, so I needed one negative, one positive. So then I wrote out the two scenarios, a negative 4 or a negative 16, added them or subtracted to see which one would give me a negative 12. And it was this one here. And now we just go back to solving. So x minus 16 equals 0, x plus 4 equals 0. So x equals a positive 16 or x equals a negative 4. Okay, so this is part 1. If you have any questions on part 1, please email Ms. Holstad and I before you go on to part 2. Part 2 is story problems and a little bit more in depth on these types of scenarios, so focus on part 1 first.